Hey class, today we're going to talk about numbers and how they're all related. And this is really cool because, as I just said, all numbers are related and they're all classified, and today you're going to learn how they're classified. So, this is called the real numbers system. First thing you need to know is that all numbers are real numbers. So real number is every number that you can think of. So 45 is a real number. The square root of 32 is a real number. 457,467 divided by 26 is a real number. Every number you can think of is a real number. Real numbers consist of 5 classifications. These 5 classifications are rational numbers, integers, whole numbers, natural numbers, and irrational numbers. So let's get into what these things are and what they mean. Alright, so first off, let's define all these classifications. Classifications of real numbers are as follows. First, like I said, are your rational numbers. Rational numbers can be expressed as a fraction. Okay, so rational number is any number that can be expressed as a fraction. An example of that would be 1/2. That would be a rational number. Now, just because it says it can be expressed as a fraction doesn't mean it always has to be a fraction. So the number 5 would be a rational number because it can also be written 5/1, which is a fraction. So 1/2 is a rational number, 5/1 or 5 is a rational number. A non-example of a rational number would be strange decimals. Okay, strange decimals cannot be written as a fraction, so therefore they cannot be expressed, or they are not rational numbers. Our next one down is integers. Integers are positive or negative numbers, not including decimals or fractions. So your integers are going to be positive and negative, the numbers you see on the number line. So an integer could be -1, an integer could be 25. Alright, an integer could be -462. But we said it's not including decimals or fractions. That's the key here. So an integer could not be 1/2. An integer could not be 0.25. Okay, an integer does not include decimals and fractions. Our next one down are our whole numbers. Our whole numbers are all positive numbers starting with 0. So examples of whole numbers are going to be 0, 1, 2, 3, so on and so forth, all the way up to infinity. But again, they are all positive numbers starting with 0. They're whole numbers, but these also do not include decimals or fractions. So non-examples would be, first off, negative numbers. Anything negative is not going to be a whole number. But also not decimals. So 0.25 and 1/2 are also not going to be whole numbers either. Our next one is our natural or counting numbers. These are very similar to whole numbers. They include all the whole numbers except for 0. So these do not include 0. Now they call these counting numbers because if you start counting, what number are you going to start with? You're going to start with 1. So natural or counting numbers start with 1 and go all the way to infinity. So 1, 2, 3, 4, 5, so on and so forth. Again, these are similar to whole numbers in that they do not include fractions or decimals. So 0.25, 0.67, any decimal or any fraction, 2/3, are not included. Also, they do not include negative numbers. So -5, -6 are non-examples of natural or counting numbers. Now we've got one more classification to talk about, so let's jump into that one. And that one last classification is the irrational number. Irrational numbers are numbers that cannot be written in the form a/b. They cannot be written in fraction at all, ever. Okay? So, irrational numbers, an example of that would be, like I said before, long, strange, weird decimals that can't be switched back and forth between decimals and fractions. Okay? So, an example would be 0.14597. Okay? We see that this decimal would go on, and I'm going to put ... on the end because I want to show that this decimal goes on forever. And also, the numbers are random. There's no way to predict what the next number would be in this sequence. All right. Also, the square root of 23. Okay. The square root of 52.65. Okay. All these are going to give us really strange numbers that are going to go on forever and not repeat. A non-example would be a decimal that repeats. 0.3333. A repeating decimal can be written as a fraction. 0.3333 is equal to 1/3. Since it can be written as a fraction, it cannot be an irrational number. So any decimal that repeats or has a pattern will not be an irrational number. Any decimal that goes on forever without repeating or having a pattern is an irrational number. And you can see that right here. You need to write this down. Irrational numbers are the crazy decimals that never end or don't have a pattern. Sorry about that. The lights in this classroom go off too quickly. So, when we're talking about rational and irrational and real numbers, we have a relationship between all of them. Okay? And this is going to be a graphic organizer. This is not an alien face. This is a graphic organizer that's going to help us define that relationship between all of these numbers. So, that relationship is as follows. Every number that we can think of is the first one we talked about. Every number is a real number. Within that, the next thing we talked about were rational numbers. Rational numbers, if you remember, are all numbers that can be represented as a fraction. So, real numbers is everything. Rational numbers are any number that can be represented as a fraction. So, those numbers are also real numbers. That's why this circle is inside of the bigger circle. Inside of rational numbers, our next one in is going to be our integers. So our integers were our positive and negative numbers, or all the numbers on the number line. Integers are not, integers are rational numbers, and they are real numbers. But it doesn't work the other way around. Not all rational numbers are integers, and not all real numbers are rational. Okay? Our next one in is going to be our whole numbers. Our whole numbers, remember, are the numbers that start at 0 and go to infinity. Well, 0, 1, 2, 3, 4, and 5 are integers. But remember, integers also include negative numbers. So whole numbers are integers. They are also rational. They are also real. But remember, it doesn't work the other way around. And our last one were our natural numbers. Okay? And just like before, our natural numbers included 1 to infinity. All of those numbers are whole numbers. And they are also all integers. And they are also all rational. And they are also all real. But not all real numbers are natural numbers. Then we have our one little group over here by itself. And that little group is our irrational numbers. Irrational numbers are the numbers that are not any of these, but they are still real. That's why this circle is separate from these circles over here. Okay? So our irrational numbers are our random weird decimals. Those random weird decimals are not natural numbers. They're not whole numbers, they're not integers, and they're not rational numbers. But everything is a real number. So irrational is still included inside the real number circle. So that's our lesson on the real number system, and I hope you learned something out of it. I hope you got some good notes.